I need to talk to everybody about choosing a lens for the Kraken camera. The lens is one of the most important parts of any camera system, and because it does the seeing, and in this case it also is where the shutter and the aperture are housed. Now, I have two lenses with me today. On your right, I have a Kodak Ektar 127mm f4.7 lens. It sits in a shutter that is made by Graflex for Kodak. So it says right on it, made by Graflex Corporation for Eastman Kodak. So this lens and this shutter are made to work together. Now, I want to point out what the lens is and what the shutter is. So there is a front element on this lens. There is a back element on this lens. So you can see that there's glass back there and there's glass in the front. So there's a front element and there is a back element. And in fact, actually, I'm going to say that there is a front group and there is a back group of lenses. I don't actually know what the architecture is of this lens, but I'm going to guess it's at least a triplet, or it might be 4 lens elements in 2 groups. So there's a front group, there's a back group, and then in between, right here, we have the shutter. Now, the shutter contains 2 different parts. So you'll see around the edges, let me make sure that I can, yeah, there we go. You can see around the edges that we have shutter speeds, and then we also have around here, we have aperture. So to change the aperture, you move this, and to change the shutter speed, you actually move this dial here. And there's an outer dial, and these things are generally a little bit stiff on camera lenses of this age. And you'll see that there are 2 ranges. There's the slow range, and this goes from B, which is bulb, and T, which is time. Time, you just hit it and it stays open. Bulb, you have to hold it open for the entire time. And then 1 second, 1/2 second, 1/5 of a second, 1/10 of a second. Now, I know that today we go 1 second, 1/2 second, then 1/4 of a second, 1/8, 1/16, and all that. But this system does 1/2 second, 1/5 of a second, 1/10 of a second, 1/25. This also, and then it has a 50th, a 100th, a 200th, and a 400th of a second. And they're in 2 ranges. So you see we have that red number right there. We have that red arrow, and we have a black arrow. So when you go from the 10th over to the 25th, you'll see that it's not much movement, but it is into a different system. And I've just done you cock the lens by doing that, and then you release it here. This also has a built-in shutter release within the lens. Now, this particular lens goes from f4.7 up to f32. Now, I want to be very clear about something about lenses of this type. They're not made, even that goes to f4.7 and f5.6, they're not made to be shot at that range. They're made to be shot f8 and up. The depth of field that you will get at f4.7 and f5.6, those are going to be razor thin depth of field. So they're not really made to be shot down here. You certainly can shoot them, and you can certainly get some really good effects, but they are not made to be shot in that range. They're made to be shot f8 to f32 right there. So this is the front element. That is the back element, and then we have a shutter and aperture system in between. Now, this is essentially the same thing. This is a much more compact design. When you look at the sizes of these shutters, and I'll talk about shutter sizes, shutter mount sizes in a minute, but if you look at the sizes of those the shutter housing, this is much smaller. It is a much newer newer one. Now this is a Schneider Kreuznach Super Angulon 65 millimeter f8. Now this has 4.5 coverage at a 65 millimeter focal distance. This is an extreme wide angle. Now I have not shot this particular one on the Kraken yet, but I have shot a Fuji version of essentially the same thing, very similar lens. Now this has a front set of elements, a front group of elements, and a back group of elements, just like the Kodak Ektar. But this group, these groups of elements are much deeper. So if we look at that versus this, I always think of this type of thing, the Super Angulon, the Schneider Super Angulon, as kind of like a rocket motor kind of design, whereas this is kind of a flying saucer kind of design. You can think of them however you want, but that's one of the things that I think of. Now, there is very little difference in the way that these two perform. There's certainly different amounts of glass, but that doesn't mean that the more glass means better. It goes lens by lens, and this one, by the way, starts at f8 and goes up to f45. So you don't even have that f4.7. You don't have the f5.6. This is a much narrower maximum aperture than this one does. Now the difference is those narrow apertures are really designed to be for focusing. So when you're focusing a camera, when you're focusing a view camera, you want to be stopped open as you can to get as much light in, and a very short depth of field so you know where in that depth of field you're focused. These are, f8 is plenty wide open for a view camera, and for the Kraken it is plenty wide open, believe me. If we figure Sunny 16 100 speed film, Sunny 16 says we're at 1/100th of a second at f16, and you can slow this shutter down and you can open it up to f8, and you're good all throughout that range. Now the biggest difference between these two lens designs is that there's a lot of glass and housing back here behind the shutter. Okay, so behind the shutter, this will fit on a helical. I'll show you how it fits on a helical. So I had to go get one of the Krakens. So this is a Kraken. This has a 105 millimeter f4.7. I think it's 4.7. Super Topcon, and this is designed for the Horseman cameras. This is a great deal. I got this for about $100. These are really cheap. Right now they're really cheap until you guys all go and buy a bunch of them. But this is the helical. So the helical moves the lens in and out. So you see, as I am rotating that, you see the lens is moved closer and further away from the film. So that's what does the focusing. The closer you are, the further you're focused towards infinity, and you want to be at this lock right here at the minimum distance. You want to be at infinity, and that's what this one is. You may end up being just a little bit, you may have to have a little bit of rotation before you can get to infinity, but don't worry about that. I also have little pieces that'll allow you to shim out the lens, move it out a little bit if you find that you have to move, if you have to focus out a little bit in order to get to infinity. So here's the big deal. Inside, this is a piece of metal. Inside this piece of metal fits right down in here in the camera. Well, it has a maximum diameter on the inside of, I believe, about 62 millimeters. That means that this component, this interior lens, the back lens, the housing for the back lens has to be smaller than 62 millimeters. And I will have the very specific measurements. I may be off on that. I'm doing that from memory. So look at what is on this page on where you are on frozenphoton.com/Kraken, and this is the lens choice web page. If you're not on this, if you're looking at this on YouTube, go to frozenphoton.com/Kraken and then go to the lens page within that, and you will be able to get to then you'll see the data, all the data, and it'll talk about all of that. So you have to be very, very careful. Both of these will work. Now, one of the things that I talked about is the ability to focus in and out. Well, the distance, so the film plane on this camera is right about back there, okay? So if we look at this, it's the back of my, in this case, the back of my rangefinder is about where the film sits in this camera. Well, different lenses have something called flange focal distance, which means that when they are focused at infinity, they have a different distance from the film plane, okay? So for instance, this is a 127 Graflex. From memory, this has a flange focal distance of about 120 millimeters, which means that from the film plane to right here at where the lens meets the lens board. So the lens board is this piece of plastic out here. The lens, where the lens meets the lens board, that's the flange, by the way. Back here is the flange where the lens meets the lens board. And that flange focal distance for each lens is different. So you have to make sure that you have different flange focal distance. So here we are. We have two different versions of the Kraken. They're actually extremely different versions. So this is a much earlier version. This is pretty close to what is going to go out. I do have one modification that has to do up here with the strap lugs. I've changed my strap lug design to for those to be metal. They're plastic, and I broke one off, and you don't want a camera falling to the ground. I didn't lose a camera, didn't lose a lens, but these are very close to the same. You'll see that their flange focal distances are considerably different. Look at how short this lens cone is. Look at how short that lens cone is. Look at how long this lens cone is, okay? So here on your left is a 65 millimeter lens. It has a flange focal distance of 70 millimeters. This is my 105, and the 105 has a flange focal distance of, I think, 120. This is just off the top of my head. I don't remember them specifically exactly. Now, I want to point out, this is a 65 millimeter lens. It has a flange focal distance of 70 millimeters. Similar, not exactly the same. This is a 105. It has a flange focal distance of about 120 millimeters. They are close. They're similar, but they are not exactly the same. So don't be taken with the idea that your flange focal distance is going to be the same as the focal length of your lens. It's going to be close, but it's not going to be exactly the same. Now, one of the things that I've done in previous camera builds, in previous homemade camera builds, is that I have built some cameras using Mamiya C lenses. Now, remember, the C is a twin lens reflex, and essentially I break those two lenses apart. I don't really break them, I unscrew them, but I separate those two lenses, and I use the one with the shutter and the aperture and all that in cameras, and then I just kind of discard the other one, which is really horrible. Don't pretend you didn't hear me say that. But the whole point is I have a 55 millimeter focal length lens that is a Mamiya C lens, and from memory, this is about a year and a half ago that I built this camera, the camera actually needs a 80 millimeter flange focal distance for a 55 millimeter focal length. Confusing. Use the table. I provided you with tables of information here. Use those tables. Really pay attention to those tables. So now I'm going to move these cameras to the side, and I'm going to be talking about that flange focal distance. So I'm moving these cameras to the side, and I'm going to talk about the flange focal distance. Now I have an oddball lens. This is a lens. The front element and the back element are actually out of a Bronica, and it is an ETRS lens. And this is a 50 millimeter, no, it might be a 60 millimeter, 50 or 60 millimeter Bronica. I've taken the housing out. I don't remember. I discarded the housing. This is really stupid of me, but I did that. Now, this lens does not quite have the coverage for a 6x12 camera. It does have coverage enough for a 6x9 camera. So I'm going to use this on a 6x9 camera, but I don't know what the flange focal distance is on this. You may have a lens and you don't know what the flange focal distance is because this data is spotty. Now, a lot of lenses were made for view cameras, and when they're made for view cameras, you just move the front bellow or the front standard in and out, and there's a bellows focusing, and you just look down. Who cares what the actual flange focal distance is? That data was not kept. Well, I care in a lot of situations. I care in this situation, so I can use this camera. So this is my flange focal distance testing system. This also may be recognized as a paper towel, paper tube. It is a tube. So I am going to, and I want to point out, I have two different kinds of tape. I have frosted tape and I have clear tape. Clear tape will not work. Discard it. Use the frosted tape. Now what I'm going to do is I'm going to put frosted tape over the end of this tube. And I hope I've gotten that long enough. I didn't do the first one long enough, so let me do that again. So that'll be long enough. So I will pull that over and I'll pull that down. Okay. Now you don't need a lot of tape, so I just use a cross. There we go. Now, this is not going to tell me what the coverage is. Now, the difference between the flange focal distance and the coverage is, flange focal distance is how far away from the lens the film has to be in order to focus at infinity. But what I'm going to do is this. Look at this. I'm going to put this lens so that the flange focal distance, so the flange is right at the end of the tube. Now, I want to point out this. I'm going to switch back to my Super Angulon Schneider Kreuznach Super Angulon. This paper tube does not go all the way around. Now, this is a small paper tube. You can get a bigger paper tube and do the exact same thing, or what you can do is, cut and this is what I've done in the past. I just cut a slit so it'll fit down so that I'm against an end. For this, I don't need to do that. Now, I need a pair of scissors. So the first thing that I'm going to do is I'm going to set my lens to time if it has it. And if it doesn't have it, I'm going to set it to bulb. So right now I'm set at bulb. I'm going to cock the lens and I am going to open the lens. So you see that the lens is now open. I am going to now put the flange in the end, and I'm going to look through the end of, through that end. Now, I don't have enough light off to the side, so I'm going to spin one of these cameras and I'm going to show you what I've got. Okay, so you can see that it's open. And you can see that there is an image that is being projected back there. And I have to make sure that I have that in focus. There we go. So now it is in focus. But I am not at my flange focal distance. And that those dark areas that are on there, those dark areas are just areas where the tape did not hit properly. I am nowhere near where I need to be. So I'm going to start cutting down. So I'm going to start cutting down this side, this end, until I am at a point where I can start to see things in focus. Now, I already know that this lens, the flange focal distance on this lens is about here. So I'm actually going to cut off a part. Now, look at that. That's horribly ragged. Or here, I'll show it to you on this side. That's horribly ragged. I need to do a much better job on that cut. I need this thing to be pretty flat and pretty good so that I can measure it later on. So I am looking at this and I'm still not cut flat. Okay. So now I have a shorter one. Let's move to the other camera. I'm going to put this on the end. I'm going to open it. We're going to move to the other camera. And we can see that I am not yet at my focal distance. So believe me, we'll be able to see it very clearly and very plainly when I'm at the right focal distance. So I need to cut it down a little bit more. So I'm gonna cut another chunk off. I wasn't close, so I've cut another chunk off. I'm gonna do the same thing. I'm gonna open it. It's helping that the sun is starting to come out there. Okay, so I am still not, okay, so you can see that through there, but it is not focused on the, it's not focused on the tape. So we're going to continue on with this process. So I think that we are pretty close to here. Got it set. Now this is not very level, so if we've got it, okay. So we are not yet, yep, we are still not yet at a point where we have any sort of focus. So let's continue on. Now I'm going to cut off much less this time. And rather than show you each little bit, I'm going to just sit here and cut off a little bit more on that. There we go. And this is going to be several very small. Okay, we're getting closer. This is going to be all some very small differences. Okay, so here's, oh, there we go. Now, here's one of the things that I want to show you. Now, if I put my fingers out there, you see how my fingers are much more, there's a point at where my fingers are in focus. See my shaky hands? See how my fingers are in focus? So that means that I am getting closer, because right now, remember, the farther away from the film plane, the farther away, the closer the focus. And the closer it is, the nearer the focus. So now let's take a look at that. Do you see how now outside that window we're starting to get some image? And there we go. And if I put my fingers out, it's further away that they're in focus. So I'm going to do it just a little bit more. And really, seriously, I don't know what the flange focal distance is. Now, this came from a medium format camera, so a flange focal distance of about like this is pretty good. But let's see. I'm going to do it some more. Okay, do you see how it's getting closer to focus? But it is not quite there. I'm going to take a look at what we've got. And Okay, so now I'm going to start taking off little tiny bits. And this is, there we go. Okay, so, and see how now we're getting much closer. Now we're getting much closer. In fact, I'm going to say, wow, okay. So now, if we look at that, and I just want to make sure that I get it in focus. Do you see how we're there? We're really pretty close there. So what now I'm going to do, I'm not going to do this on camera. So what I'm going to do, and look at all this mess that I made. Oh, my wife will be really happy. So now what I would do next, and I'm not going to take you out and do this, but I am going to just take little tiny shavings off, and I'm going to go outside where I can see a further distance. Right now, I can see about probably 20 meters, 25 meters out that window. I need to see further than that. So this, when I have it exactly right, so I'm going to go out and do this because I want to know this about this lens. When I have that exactly right, this is what I use. And I will take my calipers and I will say that the flange focal distance, now this is a lens actually I can look up. I can look up the system, the ETRS system. But I'm going to say that my flange focal distance will be whatever that number is once I get it to infinity focus. So this is, this might seem like a pain in the butt, but getting this right at this point is going to be really important. Now, I'm going to do one other thing. I'm going to tell you about one other thing. I don't know every 4x5 lens that's out there. If I knew every 4x5 lens that was out there and I could get reliable data on every 4x5 lens, I would have just made, say 80 lens cones. But you have 130 lens cones or something that are in that pack, in those packs. So use the right lens cone. And, just be okay with the fact that it may take you a couple of times to get that correct. I also want to point out there is one other reason why you may print what all of the data says is the right lens cone. You print the body correctly. You do all that type of stuff. Well, different PLA plastic has different dimensional stability, meaning that we could be off on a build, especially if we think about that, a build that's 120 millimeters deep, we could be off a millimeter, and that would change your flange focal distance. You just kind of have to kind of hang loose. This is not, a camera that is comes from the factory already calibrated. You have to do some calibration yourself. That's the fun. That's part of the fun of this. This is a homemade camera. This is your camera. These colors are different. I have orange and black on that one. I have red and black on this one. You may have black and black. You may have silver. You may have yellow, whatever. That's part of personalizing it. It's about making your camera your camera. Putting your lens on this is making your camera your camera. So I've made this camera so it is almost infinitely adjustable between, its minimum flange focal distance, really short lens cones, to 180 millimeter lens cone, which is a pretty good tele-long distance lens. Now, it's almost infinitely adjustable within that range. Now, if you want a super long lens cone that's longer than the one that I've, the maximum one that I've created for this, certainly message me. ask for that. Depending on how onerous the change will be, I may charge you a couple bucks, but probably not. If you've already bought the files, that's probably enough. But if it requires a lot of engineering and a lot of my time, I might have to charge you a few bucks for it. But my point on that is, this is, an infinitely adjustable camera from its minimum size from this one out to its, probably close to maximum size. That one, well, actually, there are ones that'll have the lens out there. But my whole point is that this is a very, very minutely adjustable and infinitely adjustable between those two extremes. So if you need any help, let me know. Read through this page, read through the optimizing page, read through all the pages. Most likely the information's there, but if not, message me, graham@homemadecamera.com. Message me, email me, and I will get back with you. I'll help you out. I'll get your cracking.